We are on page 93 today in your notes packet. Last week, the last topic that we covered in our Unit 3 notes was slope. This week, we're going to start off with something called rate of change, which, spoiler alert, is the same thing as slope. Okay, so today we're going to talk about slope, but we're going to call it a rate of change, because for most of the problems that we're going to look at, I think for all of the problems we're going to look at today, there's some sort of context. So we don't just have a set of points, we don't just have a graph. We have some sort of, again, context or background information. The graph that we're looking at, or the table, or the points that we're looking at have some sort of meaning. So that's what we're going to look at for today. But again, it's just slope. It's a new term to talk about slope. So at the top of page 93, example 1 says the graph below shows the distance in miles hiked from a camp in 8 hours. So here's how long we've been hiking. Here's how far we've gone. I want you to notice that the graph as a whole is not a straight line, but I do have sections that are straight lines. Okay, so the graph as a whole, not a straight line, but I do have these sections between hours that are represented as straight lines. Okay, so we want to find the rate of change for each of the following hourly intervals. So we're starting with hour 0 to hour 1. So that would be here to here. So I'm going to just jot down the points that I see on my graph at those times. So at hour 0, we've got the point 0, 0. At hour 1, we have the point 1, 2. I want to find the rate of change. So I'm going to find the slope. Remember, for slope, y on top, x on bottom. And I need to make sure I line up with the values that come from the same ordered pair. Okay, so here's my first point. This would be 0 over 0 minus 2 over 1. Values that come from the same point are lined up. Y on top, x on bottom, just like last week. Yes. Mm-hmm. You could, since we have the graph on this one, you could also count that, right? Since I've got zeros here, since I'm starting at the origin, like you said, I can just look at how I move, right? Since I've got the graph. I'm going to still set up that slope format because we're not going to have a graph for every problem that we look at today. So we can double check it with the graph, but I want to give you that setup as a refresher. Okay. Does that make sense? Okay, perfect. Okay, so then when I simplify this, remember we always simplify or reduce our slope, I would get -2 over -1. Negative divided by a negative is a positive, so we would have 2 here. 2 divided by 1 is just 2. And since we have a graph for this problem, we can check that. If I go up 2 and over 1, up to 2 and over 1, I can get from this point to this point. Questions for me so far? Okay, let's take a look at the next one. From hour 1 to hour 2. So here's the point at hour 1. Here's the point at hour 2. This guy is 2, 3.5. So I'm going to find the slope between those 2 points. Remember, y on top, x on bottom. So this would be 2 over 1. 2 over 1 minus 3.5 over 2. And just as a reminder from last week, if you have the order switched on these, so you started with 3.5 over 2, and then you have 2 over 1 at the back, that's fine. You're going to simplify to the same thing. So here we would get minus 1.5 over minus 1 or -1. Again, negative divided by negative is a positive, and we'd end up with 1.5. Now I'm going to do that again for hour 2 to hour 3. So here's my point for hour 2. Here's my point for hour 3. And the coordinates there would be 3, 4.5. So I'm going to find the slope between those two. Remember, y on top, x on bottom, 3.5 over 2 minus 4.5 over 3. So this would be -1 over -1. When I reduce, that's just 1. Now hour 3 to hour 4, here's hour 3, here's hour 4, and the coordinates here would be 4, 5. So 4.5 over 3 minus 5 over 4. So we would get negative 0.5 over negative 1. Again, negative divided by negative is a positive, so we just get 0.5 here, or 1/2 if you like the fraction version better. And then finally, hour 4 to hour 5. So here's our point at hour 5, and that would be 5, 5. I'm going to find the slope one more time. So that's 5 over 4 minus 5 over 5. So I get 0 over negative 1 this time. And then reduce 0 divided by negative 1 is just 0. So we called it rate of change, but we just found the slope 5 times. Okay, rate of change and slope, same process, same idea. Now, which of these hour intervals had the greatest rate of change? From what? Yes, 0 to 1. Yes, from 0 to 1 had our greatest rate of change because that was our biggest slope. And then what happened between hour 4 and hour 5? What's going on here? Yeah, they stopped hiking, right? They took a break. The hikers stopped. Our label for each of these would be miles per hour. How far did I hike over that 1 hour increment? If I'm telling you that our rate of change from hour 4 to hour 5 is 0 miles per hour, that means I didn't go anywhere. Questions for me on example 1? Okay, let's take a look at example 2. Example 2, what we really have here is a table. It doesn't set up like that with the line through the middle and the X and the Y, but it's a table. This is a parking garage displays the following sign for parking rates. What's the hourly rate for parking? So when I want to know what's the hourly rate for parking, what I'm asking here is if I park for an hour longer, how much more will I have to pay? Or if I get my stuff done an hour sooner, how much less will I have to pay? What's that hourly change in the amount I'll have to pay for parking? So how can I figure this out? That hourly change in the parking rate. Yeah, I could take the hour 2 price and subtract it from the hour 3 price. So that would be 9 minus 350. Okay. Now, here's the thing that's sort of invisible on this problem, but I'm going to write it down anyway. You took hour 2 between hour 2 and hour 3 because that's a 1 hour time difference, right? So if I want to know the hourly parking rate, subtract the prices where there's 1 hour difference between them. So what we're actually doing here is finding slope. You selected these because your bottom difference is going to be 1. So you get the price for 1 hour. Okay. And so 9 minus 350 gives us 550. So our hourly parking rate is 550. Now we can double check this because this should be the same. If it's the hourly parking rate, it shouldn't matter if it's between 2 and 3 hours or 3 and 4 hours. What's the difference between these two prices? 550, yeah. And then what's the difference between these two prices? Another 550, right? So I can check. It doesn't matter which 2 I picked. That hourly parking rate should be the same. Questions for me so far? Okay. On the next page, we're looking at a table this time. And our table is representing the height of a rocket at selected times. Okay. So here's our time since the rocket's been launched. Here's the height of the rocket at those different times. Find the rate of change between 1 and 3 seconds. So what we've done so far is find that rate of change from 1 hour to 2 hours, from 2 hours to 3 hours. Find the rate of change for the parking costs from 2 hours to 3 hours, or 3 hours to 4 hours. Here, we're not going to find the rate of change between consecutive measurements, okay? But that's okay. We're still finding slope. We're still finding the rate of change the same way. So between 1 and 3 seconds means I need this point and I need this point. In my table, my time is going to be my x and my height is going to be my y. So I'm just going to set up my slope here. So this would be 260 over 1 minus 324 over 3. And then I'm going to subtract and simplify just like we did before. When I subtract on top, I get negative 64. When I subtract on bottom, I get negative 2. Again, I want to simplify as much as possible. Negative 64 divided by negative 2 would be 32. And my label here would be feet, since that's my top. That's the first unit, okay? Feet was our y. Feet per second, since that's the x unit. So our rate of change for this rocket between 1 and 3 seconds would be 32 feet per second. Okay. So that's a speed here. I'm telling you how fast the rocket is going between 1 and 3 seconds. How is its distance changing per this unit of time? Now I want you guys to try the next one. It says find the rate of change between 4 and 7 seconds. So I would like you to do that now. Find the rate of change between 4 and 7 seconds. Check your work. Again, if you have the order swapped on these, so you have 68 over 7 first and 308 over 4 second, you would have gotten negative 240 over positive 3, but that's still going to simplify to negative 80. And again, our unit is feet per second. Now, the first rate of change that we got was positive. Mm-hmm. Okay, so I know how to Okay, I'll come check your calculator in a minute. And just as sort of a general disclaimer for today, because we're looking at problems in a context, our numbers might be a little weirder, a little larger, or have a greater range than what we saw last week when we just looked at slope between points that we had graphed on a line. So you may need your calculator for some of these today, and that's perfectly okay. Okay, so the first rate of change that we got was a positive number. What does that mean in the context of our problem? What does that mean for our rocket? Mm-hmm. Yeah, our rocket is going up. The rocket is rising. Our second rate of change was negative. What does that tell us? Go ahead, Kelly. Yeah, the rocket's falling. It's coming back down. Got your calculators with you? Okay. Okay. Good. Questions for me on example 3? Okay, again, we're just finding slopes here. So let's take a look at example 4. This time we don't have a graph or a table. All the information we need is given to us in the context. During a recent snowstorm, there were 4 inches of snow on the ground at 3 p.m. and there were 6 inches of snow on the ground at 7 p.m. Find the rate of change and interpret its meaning. Okay, so we're looking at snowfall, right? So when we are predicted to have a lot of snow or a lot of rain, what they'll tell us is the rate that we should get that precipitation, usually as like inches or centimeters per hour. So I want to start this problem by thinking about what my label is going to be. So they're telling us inches. So amount is going to be in inches per, they're giving us times that span hours. So I'm going to go inches per hour. Okay, our label is going to be inches per hour. That tells me that as I'm looking at setting this up, I want my inches to be in the Y place and my hours to be in the X place, because remember, slope is Y on top, X on bottom. Okay. The next thing that I'm going to do is sort of match up the pieces of information that are paired together. So 4 inches of snow at 3 p.m. and I'm just going to write that as an ordered pair. I put the hour in the X spot and the inches in the Y spot, so that when I go and find the slope between these 2 points, when I find the rate of change, it's set up exactly how I need it to be set up. And then it says there were 6 inches of snow on the ground at 7 p.m. So at 7 p.m., there were 6 inches. Again, inches in the Y spot, that time in the X spot, because I want my label to be inches per hour. That's a rate of snowfall. So now I'm going to go ahead and find that rate of change. So this would be 4 over 3 minus 6 over 7. So we would get -2 over -4. Negative over a negative is going to be positive, and then 2 over 4 I could reduce to 1/2. And then this interpreted meaning part is, can I appropriately apply the label that I would see here? So this would mean I would have 1/2 inch of snow per hour over this time frame. Now, tomorrow we're going to talk about something called average rate of change. And I want to kind of preview that idea with this problem here. So this is Illinois. We're familiar with snow. Yeah. So we had a 4-hour span of time here where we got a total of 2 inches of snow. So we said that means that snow fell at a rate of 1/2 inch per hour. Or we could think of that as 1 inch every 2 hours if we wanted to, but 1/2 inch per hour. Now, does that mean that between 3 and 4, we got exactly 1/2 inch of snow, and between 4 and 5, we got exactly 1/2 inch of snow, and between 5 and 6, we got no, right? This is really an average of what I could have expected over the course of that 4-hour time frame, okay? So tomorrow we're going to talk more about average rates of change, and so we're going to see functions that aren't necessarily linear tomorrow. Snowfall is not necessarily going to be we got 1/2 inch every single hour, because what happens when it snows? Sometimes it snows really heavy, right? You can barely see out your window. Sometimes it's lighter. Sometimes it's just like 3 snowflakes that swirl around in the air and don't really do anything. Sometimes it's more steady or more consistent. But that snowfall is likely going to vary over that. And it's a long, 4 hours is a long time, over that window that we're looking at. Okay, so this doesn't mean that we got exactly 1/2 inch every hour. It means over that time frame, this is a good estimate. Okay. And then our last example on page 94. An airplane leaves New York City and heads towards Los Angeles. After flying for 32 minutes, the plane has flown 192 miles. After flying for a total of 92 minutes, the plane has flown a total of 762 miles. Determine the speed of the plane in miles per minute. So here it told us the label that we're going to have: miles per minute. This also tells me that miles, I want to think of as the Y value, and minutes, I want to think of as the X value. Mm-hmm. Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Yep. Yes, exactly right. Okay. So what I'm going to do is write our sort of paired pieces of information in ordered pairs again, just like I did up here. That is helpful to me because then I make sure I match the right things up. So that's why I do that. So I know 32 minutes, I want 192 miles. My minutes, I want to be the X, so 32, 192. And then the other piece of matched pieces of information I have are 92 minutes and 762 miles. So that would be 92, 762. So I'm finding the slope between these 2 points. This is absolutely a correct setup. I'm going to show you the other option for setup based on how I've been working through these problems. We're going to get the same final answer. It's just going to be sort of a flip-flop of what we see here. So this would be 192 over 32 minus 762 over 92. And you said you got 570 over 60 here, right? So we're going to get, when we subtract, negative 570 over negative 60. And a negative divided by a negative is going to flip our answer to a positive. So whichever setup you use, this should simplify to 9.5 miles per minute. Right? That's our label, miles per minute. Questions for me on example 5? Okay, your homework today is on pages 95 and 96. I'm going to work through the first part of problem number 1 with you just to get you started. So for number 1, we are firing a piece of pottery in a kiln. It increases its temperature up to about 2,000 degrees, but it does it in sort of different sort of amounts of time. It heats at different rates. So we're going to find the rate of change for the intervals that they describe here. And I want you to notice for this particular problem, we're not looking at 1 hour, 1 hour, 1 hour, 1 hour. That's okay. We treat it exactly the same way. So we're starting by finding the rate of change from hour 0 to hour 1. So hour 0 is right here. It tells me my kiln is preheated to 200. So that would be this point right here, 0, 200. And I'm going to find the rate of change or the slope between this point and the point at 1 hour. So this would be 200 over 0 minus 700 over 1. Or again, flip-flop these, and that's fine too. So I get negative 500 over negative 1, which would just be 500. And our label here would be degrees, since those are our top values. These are degrees, temperatures. So degrees per hour. So my first rate of change is 500 degrees per hour. For B, same idea. This time I've only got a half an hour stretch. That's okay. So from hour 1 to hour 1.5, I'm going to set it up the same way. 700 over 1 minus 900 over 1.5. So this would give me negative 200 over negative 0.5 or negative 1/2 if you prefer. And then again, you can throw this in your calculator for some of these. That's fine. I wouldn't expect you to be able to do some of the crazier numbers you're going to see. So negative 200 divided by negative 0.5 gives us 400. And again, our label is degrees per hour. Now, we only looked at a half an hour increment here. That's okay. If we had done the full hour, we would have raised our temperature 400 degrees. We only did half an hour, so in that time, we're only raising our temperature 200 degrees. That's okay. I'm asking about rate of change still, so it's okay to give it as per hour. The rest of number 1 works exactly the same way. Find your points from your graph and find that rate of change. I do want to make a quick comment on number 2. For number 2, the year is your X and the cost is your Y. So we've got a table there. The year is your X and the cost is your Y. Okay, so your homework again is pages 95 and 96. You should be able to get those done by the end of the class period and not have anything to take home for today. Remember, we're just finding slope. Rate of change is the same as